Okay, so today our next topic, that is a last example, that is birds. In the previous video, we discussed about the circulation, closed type circulation, but incomplete closed type circulation in reptiles. Now that is the last example. So if you talk about birds, so there is a double circulatory system, but complete, just because as you guys all know in the birds that there were the mixing of the blood as well as in the frog. Okay, but here there is no mixing, that's why that is complete, but there the double circulation was incomplete just because of the mixing of the blood into the ventricle. In this video you will see that there is no mixing, that's why we are calling that as a complete. Okay, so as you guys all know, birds is having four chambers, two atrium and two ventricle. Okay, we are having a special part that is in the blood, that is sinus venusus. Okay, so we are having this one diagram of the, okay, mm, so let me make the chambers. Okay, so this is the heart of birds. Okay, so this is the right atrium, as you guys all know. This is the left right ventricle, sorry, this is left, you can say that the left atrium, and this is left ventricle. Okay, these are the four chambers: right atrium, right ventricle, left atrium and left ventricle. Okay, so as you guys all know, we are having sinus venusus, which conduct or deoxygenated blood from the superior vena cava and the inferior vena cava. Okay, so deoxygenated blood, as you guys all know, the here we are at the right atrium, we are having a superior vena cava. Okay, that take the deoxygenated blood from the upper parts of the body, and we are having a inferior vena cava. That means that it takes the both are the part of the sinus venusus, and they take the deoxygenated blood. So this part take the deoxygenated blood from the downward organs, okay, of the body. So they take the deoxygenated blood, and they actually, the right atrium carry the deoxygenated blood from the, you can say that there is a blood from the sinus venusus. They take the deoxygenated blood and give to the sinus venusus, and sinus through sinus venusus, the right atrium carries the deoxygenated blood. So this is the deoxygenated blood. After that, the deoxygenated blood move to the right ventricle. Okay, so now this is the deoxygenated blood. So in the left ventricle, we are having a pulmonary vein. As you all know, in previous video, we discussed about the pulmonary vein too in the frog. The pulmonary vein was conducting a, I mean that they was carrying a oxygenated blood, and through the left ventricle the oxygenated blood was carrying, and this is the oxygenated blood. Okay, this is the deoxygenated blood, this is the oxygenated blood. So you can see that the bloods are not mixed. Okay, so that's why we are calling that as a complete but double type circulatory system, because you can see that in the heart there are two bloods are there. Okay, so the deoxygenated blood will move toward the pulmonary artery. Here we are having a pulmonary artery from the right ventricle, pulmonary artery, and through pulmonary artery we are having a two arteries, that is the left lung and this is the right lung. This is the right lung, this is left lungs. Okay, so through pulmonary artery the deoxygenated blood will carry by the right ventricle and move toward the lungs. Okay, but oxygenated blood we are having a systematic artery. Okay, systematic artery, we are calling that as a systematic artery or arc. In birds this is in right side, but in mammals this is in left side. Okay, so this is in left side. So they that we are calling that as a aorta too. So they carry a oxygenated blood and provide to the bodies, and the deoxygenated blood provide to the lungs. So this type of circulation occur in the birds. So for we are having a hummingbirds. So hummingbirds are, if you talk about their beats, so they are having 100 heartbeat in 1 minute. In 1 minute, and they are smaller in size, and but their heart is larger. If you talk about ostrich, which are the, you can say that the larger birds, they are having 38 to 167 heartbeats, but they are having smaller heart. Okay, generally we talk about in birds the weight of the or size of the bird's heart, that is 2.4% weight of a body. Okay, so in this the left ventricle is chamber is thick in mammals and birds too, just because of the high pressure. And as you guys all know, they were providing oxygenated blood to the body parts, so that's why they are having thick, because they are having high pressure too, just because they providing the oxygenated blood to the body parts. So this was the last example. In the next video we're going towards the human heart with the different parts.